Okay, so we understand that in chemistry, the mole is a unit we can use to compare different amounts of things, and a mole of something is always the same number of particles. However, a mole of something would have a different mass. You know, a mole of a dozen eggs is 12 eggs, a dozen grapes is 12 grapes, but they're going to take up a different amount of space, different mass, and they're made of different things. And so that same concept applies to a mole in chemistry. When we are preparing things in the lab, a lot of times you would go to a balance and you could weigh out, say, salt, sodium chloride, and you are actually weighing out so much sodium chloride. But you know that you can also take that sodium chloride and dissolve it in water. And so then you would have salt water, and that would, of course, be represented like this, NaCl, and you would put an AQ on there. And that AQ stands for aqueous, and what aqueous means is dissolved in water. Well, if you put salt and dissolved it in water, and say you pulled 10 milliliters of this, you measured it out into a graduated cylinder, exactly 10 mils. Well, how much sodium chloride do you have? Because some of that is water, because it's dissolved in water. How much sodium chloride you actually have depends on the concentration of the solution. And in chemistry, there are different units we can use for concentration. And the one we are going to talk about today is molarity. It's a unit for concentration. And the symbol for molarity is a capital M. And molarity stands for moles of solute per liter of solution. Now, in case you're not familiar with those terms, solute and solution, let me show you this, that the solute plus the solvent, together, those would make up the solution. So if we're looking at our example of a saltwater solution, aqueous NaCl, the solute is what is dissolving, or a lot of times it's defined as the substance that's present in lesser quantity. But in that situation, sodium chloride is the solute. The solvent is water. And the solution, that's the two together. That's the sodium chloride and the water after they're combined. Okay? So realize that when you say that molarity is moles of solute per liter of solution, you're not dividing it by, well, how much water did I add to it? You're dividing it by what's the total volume when the two are combined. Because you realize that if you have an exact amount of water, if you add enough of a solid to it, when the two are combined, you are actually going to increase the volume of the two combined. And that's what the solution is. It's the volume of the two combined. So we can take this concept, this molarity is equal to moles of solute per liter of solution, and we can simplify it to maybe look like this, that M is equal to moles per liter. And when we do that, we remember that the capital M is molarity, and the moles is actually the moles of solute, and the L is the liters of the solution. And it's important also to realize when you're working with molarity that the volume has to be in liters. You can't use a volume that's in milliliters, so you're going to have to watch that, because a lot of times in chemistry, volumes are reported in milliliters because that's what we measure, but it has to be in liters. So just as a reminder there, 1,000 milliliters is equal to 1 liter. So you're going to oftentimes have to convert. But if we consider the units of molarity as M is equal to moles per liter, then what you can actually see there is that you have a formula with 3 variables: molarity, moles, and liters. And if you know 2 of those variables, you can solve for the third. Now, let's say we have a 6 molar solution of sodium hydroxide. And again, 6.0 m, what we say is 6 molar. You don't say 6 molarity. We would pronounce that 6 molar. What that means is that there are 6 moles of sodium hydroxide for every 1 liter of solution. Now, does that mean we always have to have a liter of solution? No. We could have 10 milliliters of 6.0 molar sodium hydroxide. But if we have 10 milliliters of 6 molar sodium hydroxide, we do not have 6 moles of sodium hydroxide, because we would have to have a whole liter of it to have 6 moles. If we have only 10 milliliters, how much sodium hydroxide do we actually have? Well, if we go back to this formula, what do we know in that formula? Well, we know that M is 6, and we know that the volume is 10 milliliters, and so we can solve for moles. So if molarity is equal to moles per liter, and we know the molarity and we know the volume in liters, how many moles would that be? Well, moles would be equal to the molarity times the volume in liters, wouldn't it? That's rearranging this formula to isolate moles. So molarity is 6 molar, and the volume in liters, it's 10 milliliters, which is 0.010 liters, and 6 times 0.01 is 0.060 moles of sodium hydroxide. So that's actually, if we took 10 milliliters of 6 molar sodium hydroxide, then we really only have 0.060 moles of sodium hydroxide. So to take that a step further, if we've measured out 0.060 moles of sodium hydroxide, what if you needed to know, well, how many grams of sodium hydroxide is that? That means we have to convert from moles to grams. 0.060 moles of sodium hydroxides are given, and we're going to convert from moles of sodium hydroxide to grams of sodium hydroxide. And to do that, we're going to use a molar mass, which is, we've got to add up the masses of the different atoms in sodium hydroxide. So 1 mole of sodium hydroxide is made of 1 sodium, 1 oxygen, and 1 hydrogen, because it's just NaOH. And the molar mass of sodium, if we flip to the periodic table at the front of our book, is 22.99 for a mole of sodium. Oxygen is 16. Hydrogen is 1.01. And then and so when we add those up, we know that the molar mass is 40. And so 40 grams of sodium hydroxide is equal to 1 mole. We multiply that out. And in that 10 milliliters of 6 molar sodium hydroxide, there's actually 2.4 grams of sodium hydroxide. And that's one way to manipulate the molarity equation. Okay, let's work another type of molarity problem. Let's calculate the molarity of a solution Let's do a 125 milliliter solution. That contains 13.5 13.8 grams of calcium nitrate. If we're wanting to calculate the molarity, then we have to have this part memorized. We know that molarity is equal to moles per liter. So in order to calculate the molarity, we need to know the moles and we need to know the liters. What does this problem tell us? Well, the problem tells us 125 mils of solution. So we know that the liters is going to be 0.125 liters. That's given. Do we know the moles? No. We know grams, though. We know it's 13.8 grams of calcium nitrate, and we can very easily get that converted to moles using the molar mass. The only way I'm going to get the molar mass correct is that if I know what the formula is for calcium nitrate. So hopefully you remember that. The formula for calcium nitrate is CaNO3 because we have to swap and drop. And so we know that this is 1 calcium, 2 nitrogens, and 6 oxygens. And so we're going to look up their molar masses on the periodic table. And we're going to multiply those together and add them up to figure out the molar mass of calcium nitrate. So when I multiply those together and add them up, I find that the molar mass of calcium nitrate is 164.10 grams. So what am I going to do with that? Why did I do that? Well, I need that so that I can convert this grams using the molar mass to moles. So I'm going to squeeze that in over here. 13.8 grams of calcium nitrate. And I know now that a mole of calcium nitrate is 164.10 grams. And I'm running out of room, so I'm leaving off units. Try not to leave your units off. When I divide that out, I will get 0.0841 moles of the calcium nitrate. And that number tells me what goes here. And I can divide those out. 0.0841 moles divided by 0.125 liters. And that tells me that this solution will be 0.673 molar. That will be the concentration of that solution. Now, one more useful formula that we can use with molarity. Oftentimes you will dilute a solution. Say, for example, you have some hydrochloric acid. And let's say you have 1 molar hydrochloric acid. Let's say that we have exactly 100 mils of 1 molar hydrochloric acid. If I take that 100 mils of 1 molar hydrochloric acid and I add 100 milliliters of water to it, I've got 100 mils of that, and now I'm going to add 100 of water to that. Well, it's no longer 1 molar. There's no longer 1 mole per liter. I just cut the concentration in half. When I take whatever the concentration is and I add an equal volume, I cut the concentration in half. So this would be a dilution, and what I would have now is 0.50 molar HCl, because I just cut the 1 molar in half. And that's easy to see, that if you have 100 in this example and you add 100 of water, that it just cuts the concentration in half. But what if I added some odd amount, like 32 milliliters of water? Well, it's not as straightforward then. So there's a neat little formula that helps us do that. Let's say we have 1 molar HCl, and we have 100 milliliters of this 1 molar HCl. And we're going to add 32 milliliters of water to it. When we add the 32 milliliters of water to it, our volume is going to then be 132 milliliters total volume. And the formula we're going to use to calculate, well, what is the new molarity of that solution? It's M1V1 equals M2V2. Where one side of this equation, either the ones or the twos, one side stands for the concentrated solution, the other side stands for the dilute solution. So for the example I've done here, I'm going to let 1 molar be my M1. And if that's my M1, this is going to be V1, the 100 milliliters. I'm going to let the M1 and V1 be my solution before it's diluted. This is going to be my V2, 132 milliliters, and my M2 is going to be what I'm solving for. And now I'm just going to plug my numbers in. And now what's another thing let me point out about this equation is just a second ago I told y'all that anytime you use molarity you have to use your volume in liters. Well, that's only if you're using that formula M is equal to moles per liter. That's when it has to be in liters. When you're using the dilution formula M1V1 equals M2V2, as long as the volume units are the same, as V1 and V2 have the same units, it doesn't matter what those units are. A lot of students, that confuses them, and so they'll say, I'm just going to put it in liters every time. And that's fine, if that's what you want to do. But I'm going to insert my numbers, M1V1, M2V2, and punch this into my calculator. And I will see that after I add 32 milliliters of water to this, I expect it to be diluted, and what I actually calculate is that this would be then a 0.76 molar solution. And that's when you're doing dilutions. Be careful using M1V1. A common mistake people will make is they might choose that M1 is 1 molar and they accidentally put the 132 milliliters with the M1. And so they swap their volume units. Just work on keeping that straight.